Section 6.5, example 2. Let's do another example of finding an inverse. So we've got our matrix 1, -2, 2, -3, and we augment that with our identity matrix. Our goal is to turn this into the identity matrix, and this will then be the inverse. We need to use row operations to do that. So step 1 is a 1 right here. Got that already done. We don't have to do anything to get the 1 right there. So then step 2, we need a 0. So we're going to multiply by -2 and add it here. That will give us -2 times 1 plus 2 is 0. -2 times -2 is 4, plus -3 is 1. -2 times 1 is -2, plus 0 is -2. -2 times 0 is 0, plus 1 is 1. And then our original row 1 stays the same for now. Okay. Our step 3, let's pick a different color here. Step 3 would be a 1 here, which is done without doing anything else. So that's pretty cool. And then step 4 is getting that 0 right here. So to do that, we're going to multiply this row by 2, and we're going to add it to this row. Right? So that will give us 0 times 2 is 0, plus 1 is 1. 0 times 1 is, or 0 times 2, bleh. 1 times 2 is 2, plus -2 is 0. -2 times 2 is -4, plus 1 is -3. 1 times 2 is 2, plus 0 is 2. Copy down what we already had in our bottom row, because it was already ready to go. And our inverse is -3, 2, -2, 1. Let's go ahead and try this with the formula. So the formula, you don't have to do it both ways. I'm just trying to show you both ways so that you can choose what you like in case you want to memorize the formula. So take our original problem. We're going to multiply 1 times -3 and subtract. And then we do 2 times -2. And that part right there gives us 1 over -3 plus 4. Well, -3 plus 4 is 1. So that's just 1. So that doesn't change anything. Then we take our matrix and we switch the top left and the bottom right. So -3 here and the 1 there, we just switched those. And then these two are going to stay the same place but change signs. So the -2 in this corner turns into a +2. And the +2 in that corner turns into a -2. It's just coincidence that they're both 2s. It has nothing to do with the process itself to make them the same number or anything like that. They just are. So then 1 times this whole thing gives us the same exact answer we just got. -3, 2, -2, 1. That is our 2×2 inverse. Just a reminder that that formula only works for 2×2s. I'm going to just go ahead and talk through, show you the next example that I've already written. So we have our matrix, 3, 6, 1, 2. Put our identity. Start figuring out what we need to do to get our 1s and 0s in the right places. So it looks like the first thing I did was I traded the 2 rows. That didn't change the color like I wanted to. So step 1 was trade, right? Step 1, trade rows. Okay, so that put our 1 in the top corner where we want it to be. 2, 0, 1, and then 3, 6, 1, 0 in the bottom instead. So now step 2 is to get a 0 here. So to do that, we multiply the top by -3, we add it to the bottom. So -3 times 1 is -3 plus 3 is 0. -3 times 2 is -6 plus 6 is, -3 times 0, we can just stop. We can't get the identity. We can't get a 1 there. It turned into a 0. So since we can't get this identity with our 1, 0, 0, 1, we might as well stop. There's just no inverse to this. It's not invertible. If you want to see what that looks like with the formula, do 1 over a times d minus b times c. So top left, bottom right, 3 times 2 is 6. Subtract 1 times 6, which is also 6. That gives us 0. We can't divide by 0. So we can't use the formula. It's undefined. We can't use row operations. Everything turns into 0. There's no identity. There's no inverse. That's what that looks like.